Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss factorization, highest common factor that is HCF, or in other words we can say greatest common factor that is GCF, then lowest common multiple that is LCM. Friends, we'll be discussing some problems even from calculations, divisibility test and number system. So I would just like to advise you that before attending this particular session, you must attend these session, that is calculations, divisibility test and number system, since we'll be using some of the concepts directly from these session. Okay friends, let's begin this session. Now let's discuss these two terms, that is factors and multiples. Suppose I have a number that is A, and if A is divided by B. So if we get any remainder, then B is not a factor of A. If we get no remainder, that means if we get 0 as remainder, that means B is a factor of A. That means suppose I have a number 6. If it is divided by 3, we'll be getting the remainder as 0. That means 3 is factor of 6, or we can say 6 is multiple of 3. Fine friends, let's take one more example. Suppose I have a number that is 30 by 15. Okay, so if I divide 30 by 15, I'll be getting remainder as 0. That means 30 is multiple of 15, or we can say 15 is factor of 30. Okay friends. Now let's see what is factorization. Every composite number or every composite natural number n can be expressed in the form of n is equal to a raised to p, b raised to q, c raised to r and so on, where a, b, c are prime numbers and p, q are the respective exponents are positive integers. Suppose I have an example over here, that is 60. 60 is a composite number and 2 and 3 and 5 are prime numbers. So every composite number can be expressed in the form of that is n is equal to a raised to p, b raised to q, c raised to r. Okay. Here 2, 3, 5 are prime numbers and this 2, that is exponent to 2. So every composite number can be expressed as a factor of prime numbers, or let's say one or two more examples. Suppose I have say 35. It's actually 5 into 7. Here 5 is also a prime number and 7 is also a prime number, and 35 is a composite number. So a composite number can be expressed as product of prime numbers. Okay friends, so each and every composite number can be expressed as product of prime numbers. Okay, now let's understand the terms HCF and LCM. Now first see HCF, that is highest common factor, or we can say greatest common factor. The HCF of two or more than two numbers is the greatest number that divides each of them exactly. Suppose I take an example. I have a number 32 and 36. Now both 32 and 36 are composite number, so definitely they can be expressed as a product of prime numbers. So what 32 is, it's actually 2 into 2 into 2 into 2 into 2, and 36 is also a composite number which also can be expressed as product of prime numbers. So it's 2 into 2, that is 4 into 3, 12 into 3, 36. Now we just have to see which are the numbers that are common in these two numbers. Okay, so the factors of 32 are 2, 2, 2, 2, 2, that is 5 times 2. So this 1 time 2 is common. Similarly, 1 more time 2 is common. No other number is common, that means 1 time 2 and 1 more time 2, that is 4. So highest common factor of 32 and 36 is 4. That means the highest common factor of two numbers here, that is 32 and 36, is the greatest number that divides each of them exactly. That is 32 is divisible by 4 as well as 36 is also divisible by 4, and 4 is the greatest number which is common between these two. Okay friends, so this is how the definition of HCF is discussed. Okay, I take one more example. Suppose I have a number that is 42 and other number is 48. Now what are the factors of 42? That is 2 into 3 into 7, that is 6 sevens are 42. And what are the factors of 48? That is 2 into 2, that is 4, 2s are 8, 2s are 16 into 3. Now let's see which are the numbers which are common between 42 and 48. Okay, so this 2 and this 2, 1 2 is common, then this 3 and this 3, 1 3 is common. No other number is common between these two. That means 2 into 3, that is 6 is the highest common factor between 42 and 48. Okay, let's take one more example. Now suppose I have three numbers, that is 25, 35 and 45, and let's find their HCF. Now 25 can be written as 5 into 5, 35 can be written as 5 into 7, and 45 can be written as 5 into 3, that is 5 3s are 15 into 3, that is 45. Now we see 1 5 is there which is common among all these numbers, that is, so 1 5 is there, then no other number is common, that means only 5 is common, hence 5 is HCF of 25, 35 and 45. So I hope you are clear about the procedure of finding HCF. That is, first of all, we just have to go for the prime factorization of individual numbers. Then we just have to check which are the numbers which are common among all these numbers. Okay, so it's very simple, and there are various other methods to find out HCF, which we'll be discussing just in the session. Now let's discuss the methods to find out HCF of two or more numbers. First of all, we just discussed factorization method. We have already taken 2-3 examples. Now let's discuss the method in detail. First of all, express each one of the given numbers as the product of prime factors. Then product of least powers of common prime factors gives HCF. Let's take one more example. I have a number, maybe here I am having 96, then I am having, it's say 528, then I am having 792. Let's go for prime factorization of each one of them. 96 can be written as 32 into 3, that is 2 raised to 5 into 3. Now 528 can be written as, it is 2 raised to 4 into 3 into 11, and 792 can be written as 2 cube, that is 8 into 3 square, that is 9. 8 nines are 72 into 11, that is 72 into 11, that is 792. So we have expressed 96, 528 and 792 in terms of prime factors. Okay, now let's see which are the numbers which are common. So first of all, the highest power of 2 which is common among these three is 2 cube. So let's write 2 cube over here. Then the other number, that is 3, is common among these. So it's only 3. Here we are having 3 square, but here we are having just 3. So only 3 will be common. Then we are not having 11 over here, but we are having 11 in both these numbers, but 11 is not there, that's why 11 will not be a common factor. So finally 2 cube, that is 8 into 3, 24 is the HCF. Okay friends, now let's see the next method. Now let's see the division method, that is the other method to find out the HCF of two or more numbers. Suppose we have to find the HCF of two given numbers. Divide the larger number by the smaller one. Now divide the divisor by the remainder. Repeat the process of dividing the preceding number by the remainder. Last obtained till 0 is obtained as remainder. Okay, now the last divisor is the required HCF. Okay, I just elaborate it by taking an example. Suppose I have to find out the HCF of say 42 and 66. Now I have to take the bigger number as the dividend and the smaller number as divisor. So I have here 66 and here I am having 42. Now 42 ones are 42, 6 minus 2 4, and 6 minus 4 2. Now I have got 24 as remainder. Now I'll be using 42 as dividend and 24 as divisor. So it's 24 and 42. So it's 24 ones are 24 and left with 18. Okay, now further I have to divide 24 by 18. So 24 and 18. 18 ones is 18. Now I left with 6. Now 6 divide by 18 divided by 6. 6 threes are 18. So I'm getting 0. So I got 0 when I divide 18 by 6. Hence 6 is the HCF. That is the last divisor is the HCF of 42 and 66. Okay friends. Now suppose I wish to find out the highest common factor of three numbers by division method. Suppose I have three numbers that maybe these are 21, 27 and maybe 33. Okay, I can choose any two numbers. Suppose I have chosen 21 and 27 and I'll be getting the HCF of 21 and 27, and whatever the HCF I'm getting from these two numbers, I'll be making the same calculation with 33. Let's see how it is, how it happens. It's 27 divided by 21. So it's 6, then 21, 6 threes are 18, I'm getting 3, then it's 3 twos are 6, I'm getting 0. That means 3 is HCF between 21 and 27. Now let's check whether 3 is HCF or whether 3 is factor of 33 or not. Okay, so 33 while divided by 3 will be getting remainder as 0. That means 3 is a factor of 33. Hence 3 is highest common factor among 21, 27 and 33. So HCF is 3. Okay. Now let's discuss least common multiple, that is LCM. The least number which is exactly divisible by each one of the given number is called their LCM. Okay, suppose I have two numbers, that is 15 and maybe 12. Now 15 can be written as 3 into 5 and 12 can be written as 2 into 2 into 3. Now we have to find out the LCM of 15 and 12. Okay, here 3 is common. So let's take 3 for once. Then there are 2 times 2. So let's take 2 into 2. Then there is a 5. Okay. So 3 into 2, that is 6. 6 twos are 12 into 5. 60 is LCM. Okay friends. Let's take one more example. Now let's find the LCM of 24, 36 and 48. Now 24 can be written as 4 into 6, that is 8 into 3, that means 2 cube into 3. Okay, that is, and 36 can be written as 4 into 9, that is 2 square into 3 square. And 48 can be written as 24 into 2, that means 2 raised to 4 into 3. Okay friends, now we have to take the LCM. Now what is the highest power of 2? That is 2 raised to 4. LCM is 2 raised to 4 into, now what is the highest power of 3? That is 3 square. Okay, no other number is there. That means LCM of 24, 36 and 48 is equal to 16 into 9, that is 144. It's so simple friends. Okay, that means in other words we can say that 144 is the least number which is multiple of 24, 36 and 48. Okay, it is the least number which is multiple of 24, 36 and 48, all of them as well. So you should be very clear about the definition of HCF and LCM. We'll be doing more such examples in the same session. Now let's discuss the method to find out LCM. Factorization method, which we have already discussed in the previous example. Resolve each one of the given numbers into a product of prime factors. Then LCM is the product of highest powers of all the factors. Okay, let's take one more example over here. Suppose I have to find out the LCM of 12, maybe 15, 20 and maybe 27. Now 12 can be written as 4 into 3, that is 2 square into 3. Now 15 can be written as 3 into 5. 20 can be written as 4 into 5, that is 2 square into 5, and 27 can be written as 3 cube. Now we have to choose the highest power of each prime number. Okay, so the highest power of 2 which is there is 2 square. So LCM is 2 square into highest power of 3 is 3 cube. Okay, then highest power of 5 is 5 only. That means LCM of 12, 15, 20 and 27 is 4 into 27 into 5, that is 5 fours are 20, that means 20 into 27, that is 540. Okay, that means 540 is the least number which is multiple of 12, 15, 20 and 27. Okay, now let's discuss the division method of finding out LCM with this example. First of all, let's see 22, 54 and 108, all of them are divisible by 2. Let's begin with 2. Okay, get the quotient 11, then 27, then 54. Still we have a number that is divisible by 2, so further we will divide by 2, that is 11, 27. If some of the numbers are there which are not divisible by 2, then also not to worry. Okay, here it is 27. Now we don't have any other number which is divisible by 2. Now let's begin with 3. 11 is not divisible by 3, write it as it is. Then 27 will be getting 9, then 9. Further 3, it's 11 into 3, that is 11 comma 3 and 3. Further then 3, 1, 1. Now 11 itself is a prime number, so we just divide it as it is. Okay, so we are getting 1, 1, 1. Okay, now product of all these numbers, that is 2 into 2 into 3 into 3 into 3 into 11 will be the LCM of 22, 54 and 108. Now this formula HCF and LCM of fractions. So as fractions, HCF of fraction is HCF of numerators by LCM of denominators, and LCM of fractions is LCM of numerators by HCF of denominators. Okay, we'll be doing some problem based on this formula. Now let's see what happens next. Here one more concept is there, that is product of two numbers is equal to their HCF into their LCM, and HCF of given numbers always divide their LCM. Okay friends, now we have discussed various concepts over here. Now we'll be discussing some problems, so we'll be better clear with the concept of HCF and LCM. Okay, now in the very first question, which of the following is a pair of co-primes? Okay, what are co-prime numbers? Friends, we have discussed this in our types of number session, that is if HCF of two numbers, that is highest common factor between two number, if it is 1, then the numbers are co-prime to each other. Okay, in this case 16 and 62, definitely 2 is common, hence it is not a pair of co-prime. Here 18 and 25, nothing is common between them, so it's a pair of co-prime numbers. Okay, and 21 and 35, definitely 7 is common, and 23 and 92, 23 is a factor of 92, hence 23 and 92, 23 is common. Okay, so a pair of co-prime over here is 18 and 25. Now in the next problem, find the highest common factor of 36 and 84. Now we have various methods to solve this problem. Okay, since there is none of this in the options, so we can go even by elimination of options. Let's take the highest number, that is available 18 over here. Now 36 is divisible by 18, but 84 is not, so it cannot be the right choice. Now let's see, for 12, 36 is divisible by 12 and 84 is also divisible by 12. That means among the available options, 12 is the biggest and 12 is the factor of both 36 and 84. So it will be the right choice. No need to go for any sort of paperwork. Okay friends. Now in this case we have to find out the HCF of these three expressions, that is this, this and this. Okay, now see what is the lowest power of 2, that is 2 raised to 2. Okay, then lowest power of 3, that is 3 cube, 3 square and 3 raised to 4, that means it is 3 square. Then lowest power of 5, here it is 5 raised to 5, it is 5 square, and here it is only 5, so we have only 5. 7 and 11 are not there in the first expression, so the HCF is 2 square into 3 square into 5. This is the correct choice. Okay friends, now let's see this problem. The product of three consecutive natural numbers, the first of which is an even number, is always divisible by. Okay, now let's begin with 2. So first number is let's say 2, then 3 into 4. Okay, so 2 3s are 6, 4s are 24. Okay, so we can generalize it that always the product of three consecutive natural numbers will be divisible by 24 if one of them or first of them it is an even number. Okay friends, now in this question we have to find out the LCM of these three expressions, this, this and this. Okay, now what is the highest power of 2? It's 2 raised to 5. Then highest power of 3, that is 3 square, 3 raised to 4 and 3 cube, that is 3 raised to 4. Then highest power of 5, it is 5 square and that means it is 5 cube. Then highest power of 7, that is 7 and 7 square, that means it is 7 square. And highest power of 11 is 11. So it's 2 raised to 5 into 3 raised to 4 into 5 cube into 7 square into 11, that is this option. Okay friends, now in this question we have to find out the LCM of 24, 36 and 40. Okay, let's see what happens. Let the answer be 120. Let's see whether 120 is divisible by all of them or not. 24 5s are 120, that means 24 is factor of 120, but 36 is not a factor of 120. How can we say that? So 36 is a multiple of 9, but 120 is not. So 120 is not the multiple of 36. So it cannot be the right choice. Now let's take 240. 240 is multiple of 24, but again it is not multiple of 36. So it is also cancelled. Now let's see for 360. Okay, 24 is factor of 360. Yes, because 24 5s are 120 and 123s are 360. So 360 is multiple of 24. Similarly, 360 is multiple of 36 and 40 as well. Okay, so 360 will be the correct choice among the given options. Okay friends, now let's see this conceptual problem. If the sum of 25 distinct prime numbers is even, then dash is always one of them. Friends, we know that all the prime numbers except 2 are odd numbers. So if we are going to add 25 odd numbers, we'll be definitely getting an odd number. That means definitely one of the number is even, and we have single even prime number, that is 2. So 2 has to be there. Okay, so one number is 2 and the remaining 24 numbers are odd numbers. So when we are adding 24 odd numbers, we'll be getting an even quantity, and if any even quantity is added to 2, we'll be still getting an even quantity. So 2 is the correct choice. Now let's see, in this problem we have to find out the product of 9989 into 10,011. Friends, it's just a recap of a concept of smart ways of multiplication that we have discussed in our calculation session. Let's go for a recap. It is 9989 and 10011. Here the base is 10,000 and we have to get the difference from 10,000. So it is actually minus 11 and it is plus 11. Okay, now we have to multiply 11 and 11 and put the multiplication over here. So it's 121. Okay, but since it's a negative sign and it's a positive sign, definitely 121 will be a negative number. And since we are getting the difference of 10,000, we have to fill up 4 digits with this multiplication. So I just put a 0 over here. Okay, now it's 10,011 minus 11. I'll be getting 10000. Then in the very next step, I just have to deduct 1 from this calculation, that is 9999, and 0121 to be subtracted from 10,000s. So I'll be getting 9879. Okay, so the correct answer is 99999879. That is this option. Okay, even you can go for alternative methods also, even you can apply the digital root method also. Okay friends, let's take the next problem. Now let's see this problem. The greatest number which always divides 27 raised to 2n minus 11 raised to 2n is where n is a positive integer. Okay, if n is a positive integer, then definitely it's a format of a square minus b square. In that case, a minus b and a plus b, both of them will be factor of a square minus b square. So in this case, 27 minus 11 as well as 27 plus 11, both of them will be factors. So 27 minus 11 is 16 and 27 plus 11 is 38. Okay, so it's 16 into 38, that is 608 is the correct choice. Okay friends. Now in this problem, 17 raised to n plus 7 raised to n is always divisible by which of the following if n is odd. Okay, if n is an odd number, that means it is a cube plus b cube format, or we can say a plus b format. So if a cube plus b cube format is there, definitely a plus b will be a factor. That means a cube plus b cube will be divisible by a plus b, as it can be written as a plus b, a square minus ab plus b square. That means a cube plus b cube will be divisible by a plus b. So here in this case, 17 plus 7, that is 24, will be definitely a factor of this expression. But we have not been given 24 in the options, so we can take a factor of 24 that is available with us. Here it is 3. Okay, so the answer is C, that is 3. Now let's see this problem. A number when divided by 36 leaves a remainder of 23. What is the remainder when the same number is divided by 18? Now any number that is dividend is equal to divisor into quotient plus remainder. Okay, so here dividend is divisor, that is 36. Let the quotient be x and remainder, that is 23. Now it's actually the dividend, that is 36x plus 23. If the same number is divided by 18, we have to find out the remainder. Now suppose I divide it by 18. Okay, now 36 is multiple of 18, so we won't be getting any remainder from this term. So and 23 is not multiple of 18, so we'll be getting remainder from here. So 23 while divided by 18, we'll be getting the remainder as 5. Okay, as simple as that. Now in this case, we have to find out the LCM of 120, 180 and 270. Let's find the LCM of 12, 18 and 27, since 0 is already there in each of the options. Okay, now 12, 18 and 27. Let's see which of the options are divisible by 12, 18 and 27. 54, it is not divisible by 12, so it cannot be the right choice. Now the next bigger number from 540 is 720 among the options, and let's see 720 whether it is divisible by 12, 18 and 27 or not. Okay, now 12 6 are 72, that means 72 is divisible by 12, so it can be the right choice. Then 72 is even divisible by 18, so 72 is divisible by 12 as well as 18. Now 72 is not divisible by 27, so it cannot be the right choice. Now let's see the next number, that is 108. 108, it is divisible by 12, that is 12 nines are 108. 18, yes, it is divisible by 18. Okay, now 27. Okay, 27 into 4, that is 27 into 2 is 54, and 54 into 2 is 108. That means 108 is divisible by 12, 18 and 27, all of them, so it will be the right choice. Okay friends. Now in this problem, we have to find out the LCM of a set of fractions. That is 4 by 6, 3 by 9 and 5 by 4. Now first reduce them to their lowest terms, that is 2 by 3, 1 by 3 and 5 by 4. Now what is the formula for LCM of fractions? That is LCM of numerator by HCF of denominator. Now what is the LCM of 2, 1 and 5? That is 10. And what is HCF of 3, 3 and 4? Since 3 and 4 are consecutive number, then definitely their HCF will be 1. So LCM of 2 by 3, 1 by 3 and 5 by 4 will be 10. Okay friends? So this is the correct choice. Now, in this problem, we have to find out the LCM of 22, 54, 108, 135 and 198. Okay, let's go by options. So 330 cannot be the right choice since it is not a multiple of 54, 108 and all other remaining numbers. So let's go with 198. Now let's see for 1980. 1980, that is multiple of 11 and 2 both as well. Now let's see whether it is multiple of 54 or not. For that we need to check it by 27. So let's divide 198 by 9 and then 3. So if I divide it by 9, 9 2s are 18 and 1, 9 2s are 18 and 0. Now it is divisible by 9, but now it is not divisible by 3. Hence it won't be divisible by 27 and then for 54. So it cannot be the right choice. Now let's see this number. It's suppose I directly divide it by 27. That means 27 2s are 54. I left with 5 and then 54. So 27 2s are 54. That means this number is divisible by even 22, even 54 and then 108 since it is divisible by 4 and 27 both of them as well. Okay, so it will be the correct choice, that is 5940 will be the correct choice. Okay friends. Okay, you can have an idea of 135 and 198 from here. Okay, so LCM of 22 and 54, 108, 135 and 198 will be 5940. Okay friends. Now let's see this question. We have to find out the LCM of 148 and 185. Now 148 seems to be multiple of 4. So let's divide it by 4. That is 4 3s are 12 to 8. That is 37. So it's 37 into 2 square. Okay. Similarly 185. It seems to be multiple of 5. So it is 5 into 5 3s are 15. 3 5 7s are 35. So now let's find out the LCM. It is 37 into 2 square into 5. That is 5 into 4 20, 20 into 37, that is 740. Okay friends. Now in this question we have to find out the HCF of 2 by 3, 8 by 9, 64 by 81, 10 by 27. And what is the formula for HCF of fractions? That is HCF of numerators by LCM of denominators. So we have to find out the HCF of 2, 8, 64 and 10. It can be nothing else than 2. Okay. And the LCM of denominators will be 3, 9, 81 and 27. All of them are factors of 81. Okay. 3 is also factor of 81, 9 as well as 27. So 2 by 81 will be the right choice. Okay. Now in this question we have to find out the HCF of these 4 fractions. Now HCF of fractions is once again HCF of numerator by LCM of denominator. Okay. Now what is the LCM of denominator of, that is 10, 25, 35 and 40. 5 cannot be, this 5 cannot be. Let's see for 700. 40 is not 700 is not divisible by in fact 40. So even 700 cannot be the right choice. Now that means 2800 will be the right choice for LCM. Okay, that means this is the only option left with us as the answer, since there is none of these. So 3 by 2800. Okay friends. Now in this problem we have to find out the LCM of fractions, that is 1524. We have to find out the LCM of 1524 and HCF of 36927. Now HCF of 36927 will definitely be 3. So 3 we have only in this option. Now let's see for numerator, since we have a none of these also there. So it's 1524. LCM of 4 and 5 is 20, and that is also multiple of 2. So LCM of 1, 5, 2, 4 will be 20. So it's the correct choice. Okay, friends. Now let's see this problem. Three numbers are in the ratio 1 is to 2 is to 3 and their HCF is 12. The numbers are, okay, the numbers should be in the ratio 1 is to 2 is to 3 and their HCF must be 12. In this case, HCF is not 12. Even in this case, HCF is not 12. Even in this case, HCF is not 12. Only in this case, the HCF is 12. And the numbers are in the ratio even 1 is to 2 is to 3. That is 12 1, 12 2 and 12 3. Very simple, very fast. Now, the ratio of two numbers is 3 is to 4 and their HCF is 4. We have to find out their LCM. Now, if HCF is 4, definitely the numbers are 4 into 3, that is 12, and 4 into 4, 16. Okay. Then only the ratio will be 3 is to 4. Okay. So it's 12 and 16. Now we have to find out the LCM of 12 and 16. That will be nothing else than 48. Okay. As no other number is multiple of 12 and 16, both among the options. Okay, friends. Let's see the next problem. Now let's see this problem. In this case, the sum of two numbers is 216 and their HCF is 27, and we have to find out the numbers. Since both the numbers are given in the option, let's check which of the numbers are making sum as 216. Let's see the first option. It's 189 plus 27, that is 216. Okay, and their HCF is also 27, since 189 is multiple of 27. Okay, so A will be the correct choice. Friends, in this case the HCF will be 108, so it cannot be the correct choice. Though we have got the correct choice, then also I'm just taking examples. In this case the sum is not 216. Even in this case the sum is not 216. Okay, friends. Now let's see this problem. The sum of two numbers is 528 and their HCF is 33. The number of pairs of numbers satisfying this condition. Okay, if HCF is 33, then we can assume the number to be 33x and 33y. Okay, now 33x and 33y. Now 33x plus 33y is given as 528. That means x plus y is equal to 528 by 33, that is 16. Now we have to find out the number of pairs which are giving the sum as 16. I have x, y, that is 1, 15, 2, 14, 3, 13, 4, 12, 5, 11. Then I write over here 6, 10, 7, 9 and 8 and 8. Okay, so it looks like that we have 8 pairs, but friends, it's not like that. Since we have to maintain the HCF as 33, we need to choose the pair which are in which the numbers are co-prime to each other. See, in this case, which is there in this, there 1 and 15. In this case, 2 and 14 are not co-prime to each other. That means their HCF will be coming to 33 into 2, that is 66, not 33. So we cannot take the pair of 2 and 14. Similarly, we can take the pair of 3 and 13. We cannot take the pair of 4 and 12 since it will not give the HCF as 33. We can take 5 and 11. Then we can take 7 and 9. Okay, in all these 4 pairs the numbers are co-prime to each other, so they will maintain the HCF as 33. So we have 4 choices. Okay, friends. Now let's do this problem. The HCF of two numbers is 12 and the difference is 12. The numbers are, let's see from the options, 66 and 78. Their HCF is not 12 since none of them is divisible by 12. So it's not a correct choice. Similarly, 70 and 82, none of them is divisible by 12. So it won't be the right choice. Similarly, in this case, 94 is not a multiple of 12, so even it won't be the right choice. So here in this case, 84 and 96, both of them are multiple of 12, as well as the difference is also 12, and we don't have none of these over here, so it will be the correct choice. No need to cross verify. Okay friends, now let's see this problem. The product of two numbers is 4107. If the HCF of these numbers is 37, we have to find out the greater number. Now if HCF is 37, then let's the numbers be 37x and 37y. Okay. Now their product, that is 37 into 37 xy is equal to 4107. That means xy is equal to 4107 by 37 into 37. Now if we divide 4107 by 37 into 37, we'll be getting 3. Now we have to choose the pair when the product of two numbers is 3. Okay, since 3 is a prime number, we'll be getting product 3 as only when one of the number is 1 and other is 3. So we have choices for x and y is 1 and 3. Okay, now we got the numbers that is 1 and 3. We have to find out the greater number. That means the smaller number is actually 37 into 1, and the greater number is, that is 37 into 3, that is 111. Okay friends.